So we're going to look at a quadratic word problem here. Again, a quadratic word problem is just a problem that involves a quadratic equation. Usually these come into two different forms. One form will be asking you for the maximum or minimum value of an object, usually after it's been launched or thrown, or if you're doing a projection for a business about how much profit they made, it could be the maximum profit they make and how long it takes to make it, that sort of thing. And the other version of the problem is the x-intercept version, which is usually asking when something is equal to 0, most likely the height of something. So if you threw a ball in the air, you have two ways of describing it. You can find the vertex, which is when that ball reaches the maximum height, or the x-intercept, which is when the ball has a height of 0, or put another way, when it hits the ground. So those are the two types of problem questions you can see that deal with this situation. Usually I do 2 or 3 examples. In this case, I'm just going to do one example, but the 2 different versions of that one example, so we can get some exposure to both. So we're going to start with this one here. It says a rocket is launched from a hill. The height of the rocket is given by the following equation. I'm going to put in here x equals the time in, we'll say, seconds, and then h, of course, being the height. So the first question is asking me, what is the maximum height of the rocket? Well, maximum means vertex. Anytime you hear the word maximum, minimum, lowest, highest, anything of that sort, that's your clue to find the vertex. So I'm going to go to this problem here, and the way I find the vertex is I find it in 2 parts, the x-coordinate and the y-coordinate. Now remember, my x-coordinate is going to give me the time, and my y-coordinate is going to give me the actual height. So when I find my x-coordinate here, that's not going to mean that I'm done. That's going to give me how long it takes to reach my maximum height, not how far my maximum height actually is. So to find the x-coordinate of the vertex, you do the following equation. X equals negative b over 2a. That will give you the x-coordinate of the vertex. So we go to our equation up here. Remember, b is the coefficient of the x term, so b is a number attached to the x. A is a number attached to the x squared. So if we go through this here, opposite of 64 is negative 64, so that's why it says negative b. If my 64 is positive, I want the negative version of it. And then 2 times a, my a is negative 16, so I'll put a negative 16 there. Doing some quick math, negative 64 over negative 32, that's just going to be 2. And again, this is an x-coordinate, so it's going to be 2 seconds. So what this tells me is that it takes 2 seconds to reach the maximum height of this rocket here. So this rocket is going to reach its max height in 2 seconds. But I still don't know how far that maximum height is. So I'm going to go back and plug that 2 into the equation to get the height. Because remember, this equation says, give me your x's and plug them in here, and I will get you what your height is, what your h is. Well, I know what x I want to plug in, so I'm going to go ahead and do that and figure out what h I get as a result. So negative 16 times 2 squared plus 64 times 2 plus 80, and that's going to give me my h. So again, doing some quick arithmetic here. Negative 16 times 2 squared, that's negative 16 times 4. So that will get me negative 64. 64 times 2, that's going to be positive 128. And 80 is going to stay 80. And if I add those all together, I get a nice 144 feet. So that is how high my rocket will be at its max height, and this is how long it will take to get there. So my rocket will achieve its maximum height of 144 feet 2 seconds after it's been launched. Okay? So a pretty fast-moving rocket. So the next type of problem that you'll see here is the x-intercept problem, or I guess you could call it the quadratic form problem or question, because we're going to need the quadratic equation usually to solve these, although some of them could be factored as well. So it says, how long will it take for the rocket to hit the ground? Well, let me rewrite my equation here so I can scroll up a little bit. Negative 16x squared plus 64x plus 80 equals h. Make that 80 a bit nicer there, 80. So what this is asking me for is it's asking me, when is my height 0? Because that's what it means to hit the ground, right? It means to hit the ground when your height is 0, because this is the height above the ground. So it's basically asking me to solve this. Negative 16x squared plus 64x plus 80 equals 0. I want to know, when is the height 0? I want to know, since h is 0, what is x? And we've solved these before. This is a quadratic equation that is set equal to 0 for us already. So we're going to solve it by either factoring or using the quadratic formula. Now, most people will go straight to the quadratic formula because these are big numbers. However, this is a factorable equation. I'll leave it for you a little bit to see if you can factor it out. But one of the key things about factoring this is that you want to divide everything by a certain number, because negative 16, 64, and 80 have a few numbers in common that you can simplify them with. So for example, if you divided everything by 2, your factoring would go a lot easier. If you could divide everything by 4, it'd go even easier, and so on and so forth. So think about the biggest number you can divide all those numbers by and do it, and then factor what's left. But like I said, most people go straight to the quadratic equation. So that's what we'll do here. So we're going to have some space here. The opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, I'm not going to go through every step here because I'm confident in your ability to do some calculator work. Again, just work from the inside out. 4 times negative 16 times 80, then do 64 squared, then add or subtract them together depending on what's left, and go through that whole process there. So I'm going to put a few dots here, and that's just calculator work. And what you should end up with is two answers. You should end up with a -1 and a +5. Now, both of these are not my answers, though, because it's impossible to hit the ground twice. One of these answers does not make sense in my problem. Because remember, my question is, how long will it take to hit the ground? So my answer is a time measurement, because it's asking how long it will take to hit the ground. And it doesn't really make sense for my time to be a -1 second. So what I'm going to do is I'm simply going to eliminate the -1, and +5 will be my answer. So it takes the rocket 5 seconds to hit the ground, because -1 seconds wouldn't make any sense. That's just a problem you have with quadratics, is that oftentimes they will give you an erroneous answer as well as the correct answer, and you have to know how to decipher which is which. So then the whole thing boils down to know whether you're trying to find the vertex or the x-intercepts. If you're trying to find the vertex, which means your problem's asking you what's the lowest, highest, maximum, minimum, that sort of thing. If you're trying to find the vertex, you use the first thing we did, which is the -b over 2a, to find your x, and then you plug that in to find your y. If you want to find the x-intercepts, which is basically when something hits the ground or when something achieves a 0 mark, so if you're talking about the profit of a business, if it's going down, that'd be when the profit is 0. If you're trying to find something like that, then you use the quadratic formula, or if you like to, you can use the factoring as well, as it scrolls down here to show you. So this is all what you do for the x-intercepts. Notice you don't have to plug anything back in for the x-intercept. You just get the x-intercept and you're done. So in some cases, it's a little bit quicker than the vertex. Hope you enjoyed the video. Have a good day.